measuring people as a system. We're trained into our 30s to like work in a silo, right? So it was like a whole breakthrough for me. I had to break out of my silo and go, wait, I should start designing studies that measure people as a system, how they're feeling, how they're thinking.
You're listening to Parallax from Radcliffe Cardiology in association with makeadent.org. Here is your host, Ankur Kalra, MD.
Hello, everyone. Welcome to another episode of Parallax. Welcome to another Monday. Thanks for tuning in. My guest on today's show is Dr. Leslie Saxon. Dr. Saxon is professor of medicine and a clinical scholar at University of Southern California, Keck School of Medicine. She is also the executive director for the University of Southern California's Center for Body Computing. And whilst we were having a conversation offline before I started recording, she informed or educated me that this was actually the very first center at an academic health center, which was inaugurated in parallel with the first iPhone, with her vision of sort of helping us live healthier lives through the concept of life care and not only sick care, another concept which we were discussing off the record. And I'll request her to, shed some more light onto these concepts. So Dr. Saxon is, a practicing cardiologist. She's a clinical cardiac electrophysiologist. She's also boarded in heart failure. And there is a very interesting tagline to her center, which is Healthcare and Human Performance Reimagined. So with that introduction, Dr. Saxon, thank you so much for doing this for us. Thanks for your time on a Friday afternoon, and welcome to Parallax.
Thank you very much, Ankur. I didn't know if I was going to do this when I received the invite from your publisher, but I listened to a couple and I liked them. So congratulations. I think they're quite good, and I'm happy to contribute if I can.
Yes, absolutely. No, it's our pleasure to have you on board as one of our speakers for Parallax. So I'm going to start by asking you, when you sort of imagined this Center for Body Computing, and you work with professional athletes and also the military. What was your vision when you were designing the center at USC?
I was at the time that I founded the center, I was in a relative position of strength because I was the chief of cardiology and we were building a heart institute. But at the same time, and I was doing the typical things, doing a lot of cases, doing clinical trials, helping build an academic heart center. And my sort of one of the things that that my research focused around for years was the development, sort of the role of defibrillators, taking defibrillators from secondary prevention with a total implant rate in the United States of like 40,000 devices for people who were lucky enough to survive a cardiac arrest. Early in my career, I helped design some of the clinical trials that help those defibrillators get indicated for primary prevention of sudden cardiac death in the setting of heart failure or left ventricular dysfunction. And then I was one of the founding investigators and helped design the trial of cardiac resynchronization therapy for heart failure. And that indication was hugely important because then the defibrillator wasn't just sitting there waiting to go off should you need it, but the value proposition was really there because, heart failure patients with conduction disease, which is probably up to half of the really sick patients, they were suddenly feeling better, living longer, and the defibrillator was just sort of extra, right? So that took implant rates from the 40,000 a year to, in the kind of the heyday, 20,000 a month we're going in. And soon after that pivotal trial, which was just that whole therapy and development of that therapy was just incredible because suddenly, patients got so much better immediately. You could titrate on drugs. I mean, it was life-changing in many ways. But right after that, as sort of a follow-on, a company that I'd done the pivotal CRT trial with, Boston Scientific, connected their devices to the network. And I thought, okay, that's really interesting. So about half of the clinics in the country provided their patients with the ability to transmit data from their defibrillators to their medical center. And about half the medical centers, even though there was no cost associated with it, and at that time it was even the company even gave people a blood pressure cuff because a blood pressure cuff was sort of essential to titrating heart failure medications in a really sick class 3, 4 population. So anyway, and I went to Boston Scientific where I had some stature because I just done this trial that was positive, resulted in a Medicare coverage rate and a lot of implants. And I said, well, let's study this. Let's study outcomes when uh, devices are connected to a network in half the country and in half they aren't. Let's look at like death rates. Let's start to look at this. And we did through a data use agreement. We did the first study and we had like 67,000 patients. And we showed that survival was 3.9 times as long if you were connected to a network with a defibrillator than if you weren't. And I remember submitting that paper. I don't know if it was published in Circulation, but I think we submitted to the New England Journal. And the reviewer, who's a well-known cardiologist, reviewed the paper, and he was like, "I've never known Dr. Saxon not to be honest, but there's no way she got 67,000 patients in the study." Right? That was the beginning of digital kind of big data research. And why? Why would people live longer in addition to the mortality benefits of a defibrillator by being connected to a network when they weren't seeing the data? Only the clinicians were. And the reason was that I think the very first time you had atrial fibrillation and you had a defibrillator, we diagnosed it and notified physicians. So, there goes your stroke risk, right? If you're treating it right away. People were getting atrial fibrillation and therefore not receiving CRT therapy in many cases because they were natively conducting more rapidly in AFib. And so their heart failure would worsen. But if you were able to diagnose it and treat it and reestablish the therapy that the device was intended for, you could avoid a hospitalization, decompensation, whatever. If the device malfunctioned at all or there was an inappropriate shock. I remember because I follow so many hundreds of defibrillator patients my whole career, I remember this vividly. I had a congenital heart disease patient. I'd put a defibrillator in. It was New Year's Eve and they lived like far away from LA. And with the ability to look on a website, the patient had had a syncopal shock. And I was able to go on the website and actually see what the rhythm was. And that took about 9 or 10 hours, gave us, both of us, back our lives for that 9 or 10 hours because I could tell the patient what it was. I could make a mitigation plan without them having to go to an ER, call a device rep, et cetera. So with that study and that whole research initiative, I became fascinated with a couple things. Number one, even though electrophysiologists are very technical and technically savvy compared to other, say, specialists, the sort of nihilism that surrounded this new piece of data. In other words, if you looked at remote data, you could improve patient outcomes. Many doctors were just nihilistic about that. They're like, we don't want to know. They perceived it as some sort of threat, either through a legal action or something else. They didn't consider the threat of not looking. So, this sort of resistance of traditional medicine to change in the way we so identify in our silos. I don't really want to manage heart failure, even though I put defibrillators in for heart failure. I implant devices. I don't do that. I'm not going to do that. And the company as well, while they were indulging this data rate and this data analytics project of mine, they couldn't monetize it. And so then there were a couple of FDA advisories on devices. And we started understanding that, these advisories really had to be looked at because if you just issued an FDA advisory on a lead problem or a defibrillator problem and electrophysiologists started taking them out without more high fidelity information, they could introduce more harm than protections. So we started looking at using these large network devices all across the country to sort of survey and scope and scale and understand more deeply device malfunction. Because prior to that point, if a patient came in and you saw that their lead impedance on their device was off, you'd have to literally manually enter it into a very unwieldy FDA database. So it didn't scale. And then the device company saw that we started looking at all their device legacy devices, new generation devices, and we discovered that the Boston Scientific devices at that time, their battery life was like 5 years longer than any other company because of this large database. Well, that was a big selling point. That started to monetize this investment, this digital data for them, right? Because that really differentiated them. So through that time, I was like, oh, this is unbelievable. And I became sort of a real enthusiast on network data and being able to capture patients' behavior and things at the earliest possible time. Again, this is all in chronic disease patients, but also, the kind of interesting conversations you could start to have with patients who thought they were actually participating in their care and that you were seeing them at home. And I started doing studies where I saw that just having that communicator in the home drove patient adherence to medications because they thought you were watching them, even though you weren't in that way, right? But I started sort of thinking about, why don't we enfranchise patients more in their own care? Maybe because I was always involved with high tech, expensive medicine and Medicare payments and clinical trials. I was like, maybe our outcomes lag behind in this country because we just don't knit it together and enfranchise the patients. Because I know we have the best doctors, the best technology, the most opportunity to innovate. Why don't we have the outcomes, And I got so sick of getting the lecture on why England's better. Some healthcare system I knew wasn't, quote, better, right? I just got sick of listening to that. So I was like, okay, why aren't we delivering these? And then I decided to found this center to try to understand how to get network data off patients all the time and how to use that to enfranchise patients and create a different healthcare system, different from the one I'd spent my, entire life slaving in and a really rewarding, great career. But no matter how many hours a week you work, particularly if you're an interventionalist, and no matter how many dinners you miss with your kids on Friday night or whatever, and to stay and talk to the patient who may be still feeling the effects of the Versed or the fentanyl or whatever, you can never really provide the service, right? They come back in on the post-op visits like no one ever talked to me. It's just very hard to drive the understanding across the system, particularly for patients and their families, to give them what they need to produce a good outcome after discharge. So frustrating. So I decided to, start this center and start to look at that stuff. And the only real product that was out there in the consumer space at the time was the iPod. Because I'm a music lover, like, God, and I'm going to like these meetings with electrophysiologists and about devices and ablation and stuff. And I'm like, if we could just like create a product and where on demand you could get information if it's entertainment, or if we could combine entertainment with care or tell a different story around care, just trying to drive these outcomes and use technology. And I had some credibility, so I didn't get laughed out of the room because it was science fiction in a way. But and I got the guy who designed the iPad and made it a product for Apple to speak at my conference and start to talk about how just computing form factors could be applied to medicine. Like the iPad was very early in the global war on terror. The iPad became the kind of navigation device for pilots that just saved them tons of time rather than the maps and stuff. And because that conflict scaled up so quick, and it just so I was really interested in some of these shortcuts. And then the iPhone's out, then the iPad's out, then the watch comes out right in 2015. So there's this incredible kind of 10-year development of consumer devices. And the watch starts to get, I start studying it right away, and it starts to get some level of FDA class 2 clearance on its algorithms and starts adding more and more medical grade capability. And then I was like, okay, this is great. This is a great way to engage patients. And now a lot of medical devices, regulated medical devices, seem so arcane, like the implantable loop recorder, right? If you have an Apple Watch, why would you need an implantable loop recorder as long as you charge it and wear it all the time? It's very hard to almost imagine the kind of use case for that, or the value, or even something like a Zeo patch, right? So I uh, began thinking about, in a lot of the clinical trials I was doing in chronic disease and medicine and heart failure, and then I started doing a lot of stuff, say I'd always been active in professional sports around the sudden death question, but I'm just a huge sports fan, and I'm really interested in elite human performers, not only sort of looking under the hood and trying to understand why they're so fragile, right? Why are certain populations of elite performers sort of like elite racehorses? They can go down, right? What is the perfect storm of that? Why does that happen? It's very interested in that, as well as just trying to continue to deliver insights into human performance. And so that was all kind of happening. Cloud storage came, worldwide networks. The cell phone became the dominant computing platform of our time, right? It wasn't when I started the center. So other wearables were coming on board that were fairly accurate. And then it became like, oh, wait a second. We can create a non-bricks and mortar health system that really engages the population, drives healthcare from wellness to chronic disease, and probably most importantly, sort of fills in the gaps between health and disease, which we know like nothing about, right? But to be able to start to detect that. So then, you know, and then AI is a whole other thing we can talk about. That's the kind of the latest entry into this sort of problem in this new um into this new system. But um the second thing that happened to me was I was encouraged because of my work in elite athletics, kind of toward the drawdown of the global war on terror, to start to work with some other elite human performers, the military. And that resulted in, probably $20 million, maybe short of $20 million in DoD funding over the years. But a really fascinating journey for me because I was pretty ignorant about the military. And that, I think, made me good because I have an opinion about a lot of things. And I was able to kind of just listen and learn their problem set, and then design some digital stuff to study and hopefully enhance their health. Because at that time, with the drawdown of the war, you had people who were, you know, 30 to 45 to 50 who literally fought 20 years of war, high tempo combat deployments repeatedly. And they had these signature illnesses, which were kind of fascinating, not just TBI, but deafness, 500 times the rate of sleep apnea of age matched cohorts, um, a sort of a hypervigilance, hypersympathetic tone, like a whole bunch of fascinating symptoms, probably again due to this perfect storm of exposure. Then a general said to me, he was helping me sort of understand what their need set was from a health perspective. He said, God, I just wish you could figure out a way to measure us as a system like we do our weapon systems and maintain us throughout our life cycle and enhance us like we do our weapon systems. I'm like, oh, that's interesting. And at the same time, I was sort of being, started thinking about how many comorbidities all my patients had, and how I never really even thought about the diabetes or the obesity or whatever the comorbidities were. I'm like, oh, measuring people as a system. Wait, we're trained into our 30s to like work in a silo, right? So it was like a whole breakthrough for me. I had to break out of my silo and go, wait, I should start designing studies that measure people as a system, like how they're feeling, how they're thinking, how that relates to how they slept, how that relates to their metabolism, to their heart rate variability, or whatever measure of cardiac health I was looking at, or overall health. And then we started to do it. We started to build a software platform, take medically regulated sensors, take consumer sensors that we could validate, and measure warfighters, active duty warfighters, mind and body, so that they could ultimately be able to do the hack on themselves and figure out what the right conditions were to maintain their health after they, fought this long war. And I felt very kind of responsible to them because, number one, I hadn't really known the extent of the health consequences of that conflict. But, we sort of felt like we owed it to them to give them cutting edge in the moment medical science, because they'd taken risk and given us really their use, right? And so I felt just incredibly honored to work in that community and partner with them to design this type of health and human performance management. And I just learned so much. And that's where we are now. So now we have a platform that can manage people on demand 24/7 and deliver insights in advance of a health event, hopefully push out that health event but also to help them manage any chronic conditions. So we're taking that, we're growing it, we're applying it to surgeons. We're doing a study, a surgical wellness study, to see how residents and surgeons perform. This stuff is pretty delicate, though. Think about yourself, Ankur. I mean, you may go to work some days and have 7 cases, and maybe you're up with the kids all night, or maybe you're just up all night, and you're not really going to out yourself on that, because what's the upside for you? You're trained to do that, right? Yet it's probably pretty important to know. And I think about a lot of these warfighters tell me stories about how they can be somewhat brain impaired, and forget things. And I remember many nights just driving home after long days, and forget and not being able to like recognize my exit. Now, I just done complex cardiology cases, my exit on the highway, and so I think I did those pretty well. But your reaction time and other things does suffer from that kind of fatigue, and we're now able to quantify that. We've actually shown that the amount of cognitive degradation and what order it happens with extreme fatigue, and we can show it for each individual, and it's not the same for everybody. So those are the kind of insights, I think, on a personal level that are pretty helpful to know, because you might not do this complicated case last, or whatever. Even though you are trained to do that under fatigue. So it's been kind of a really interesting ride. But a lot of it's like better lucky than good, kind of been enabled by this growth in technology.
Yes, I mean, it's fascinating to hear, everything that you've shared. And, it's the topic for today's discussion is wearables and how we can enhance risk assessment, cardiovascular risk assessment, for a supposedly healthy population. And I think what you've described here is nothing short of science fiction. And the fact that it's not fiction anymore, the fact that you are actually executing this, and it's you are garnering data which are novel, and are providing novel insights into even fatigue is incredibly fascinating. So I want to ask you, for example, a use case scenario here. For example, if I walk into your Center for Body Computing and say, hey, Professor Saxon, I've heard you do incredible things. I just want a measure of my human performance. Am I as optimized as I can ever be as a human? What all two parts to this question. The first part is that even feasible in 2025? And if it is, then the second part of the question is, what all will I get hooked up to, in terms of devices? Um, and then what all will be measured? I think that would be fascinating to hear from you.
Yeah, so it's both things, right? So it's software is a huge part of this, and then services are a huge part of this. But the hardware and the computing devices, as you point out, what are they, right? What are they the future? Right now, for us, what they are on, say, if a person doesn't have an implantable device or something, it's some measure of metabolism. Metabolism is huge. So, say it's a CGM, continuous glucose sensor. Those are very soon going to be equipped with ketone and lactate sensing, like a reading a minute. One of the problems with getting these readings in like non-diabetics, or if you're using lactate, whether you're trying to use lactate to predict sepsis, or you're trying to use lactate to predict, to try to train somebody to recover from an injury, or you're trying to use lactate just to better train somebody as an endurance measure or something else, is that because you're not used to seeing the data continuously in normals, you have to like live with it for a while to understand what it means. It's not just like an immediate insight. So we get some measure of metabolism. We get some measure of cognition, how your brain's working, some measure of basic things like sleep, activity, uh, blood pressure. The evolution of diagnostic sensors is taking a huge leap. So there are companies like there's a company called BioLink, for instance. It was founded by the guy who ran Dexcom and got it through FDA the CGM through FDA approval for them. So this company has a small chip that can do blood work from the skin, but tumor markers, glucose, hemoglobin, like, you know, be worried if you're LabCorp. So imagine if you could get a continuous set of continuous blood markers on somebody, right, in the moment. So you've got that. You've got measures of metabolism, ketones, lactate. You know what you ate. You have activity. You have sleep and cognition and emotion. And now you're starting to, in heart rate and heart rate variability and arrhythmia burden. And now you're starting to understand how the body works as a system. I think one of the things that's primed the pump for us subspecialists also in medicine to start thinking that way, and I'm sure you've thought a lot about it. You had a podcast on it, is like you think about the GLP-1s, right? Resetting that gut brain connection. How many patients have you had that have come to you and gone, oh, now I know when to stop eating? It's not just that the drug is delaying gastric emptying, right? It's like it has a neurologic effect. There's a disorder, there's a neurologic disorder that it's addressing in people, right? And so I love that because it constantly reminds me of how much we ignore that the body is a system and how all these different organ systems relate to each other, which we understand very little about. The other part of the discovery here is the more we measure individuals, the more we realize that everybody's a fingerprint. People, I mean, really are unique in this way. You can take on the elite athletic side, a position in football, say a wide receiver, you can take an individual, and I've done these studies, trying out for the combine. They have the same elite performance records in college. They go to the NFL, they have a great performance record in the NFL. Under the hood, just heart rate behavior, completely different. Metabolic behavior, different. The way they activate in the first, say their glutes in the first 10 yards of a 40-yard dash, different. So the more you measure and the more high fidelity measures you get, the more you realize there's a lot of variation. Here's the good news about that. You know how we think of things in medicine is fixed and not very functional, like this is your personality type, you're a pessimist. This is your left bundle branch block, it's fixed. What we're finding is that a lot of these things are actually functional. They're not fixed, so you can cultivate them into a different state if you understand them as part of a system that's influenced by other things. So that gives me sort of great hope that a lot of things we thought we couldn't change, either in the psychological realm or even in the conduction disease realm, we actually can, and we can figure out ways to cultivate certain of these traits back to a health state by influencing some other aspect of the system. I mean, that's crazy. I don't know why I think that's so profound. It's just because I've never thought that way before because I could never measure all this stuff, right? So we weren't forced to think that way in a way because of just the way we're structured. And that's how I'm thinking now. And that's sort of a really interesting place to try to think and innovate when you haven't ever really been really worked that way. Um, but if, it's probably time for us to start addressing things that have amazing influence on all the stuff I'm talking about. Very basic things like nutrition, which we know very little about, not to mention on an individual basis, right? But we need to start addressing just because of the sort of public health crisis of obesity and such. So I think that this type of model will apply to a lot of different things and will hopefully, greatly surpass what we've been able to do as bricks and mortar healthcare, not to minimize what we've done or the great discovery that's happened, but it doesn't work as a service model at all. It just doesn't. Because people are outside of our bricks and mortar most of the time. And so we need something else, right? And it's got to be based on data and AI. To your question, AI is going to accelerate it even more. What are the computing devices, not just wearables? That's like that already feels outdated to me, even though I'm talking about it. There's an Israeli company called Bina AI that takes your picture from any smartphone and can get your blood pressure, hemoglobin, A1C. You can measure blood pressure whenever you take a picture, right, of your face. So these continuous measures, what are the computing devices going to be? Is it always going to be the phone? Sam Altman, who started OpenAI, and Johnny Ive, the great designer for Apple, they formed a company to envision and design. I think Altman bought Ives company. It was called, who's making design company, and they're designing AI computing products, right? Because if you think about AI, it's like, okay, ChatGPT is amazing, but you got to flip open your computer. If you've got it on your phone, you go ask it a question, get the answer. What's the best computing device to really advantage AI for health, right? Is it like they're doing something allegedly that you wear around your neck that's got cameras? Maybe it's environmental conditions. Environment is very important to health. It's a big important factor in health. What if there's something that can help you, figure out what predictors of social determinants of health and how to help people who are disadvantaged in that way get better health outcomes. So I think that question you're asking about, what's the hardware piece of all this, is super interesting. The other thing OpenAI has done, which is a crazy story not many people know about, is they have this company called World. I guess they got worried about, I guess they got worried about in the era of AI, how do we authenticate the human, from say a bot, right? And so the way they came up to do this was to scan their retina. So World has all these retinal scanners that they first took to like Kenya and Argentina, and they couldn't get people to do it. So they started a cryptocurrency, and they pay people in this World coin to get their retina scanned so they could, quote, authenticate them as human. So it was like the equivalent of like $10. So they did a bunch of people in like Kenya and all over the world. And then the governments got wind of it and say, hey, we authenticate the human. What are you doing? Like, we have passports and we don't like this retinal thing. I got interested in it because retinal scanning is turning out to be a very good way to assess blood work and the presence of infectious disease and some other disease states. And I thought, wow, do we really want a new technology company having health and authentication data, right? That's like a big, crazy problem of AI. And what's the hardware? Is it a diagnostic and an authenticator, right? How crazy is that? So I think that these emerging computing systems are going to be super fascinating to watch, and where they cross over between, say, authenticating the human and health devices is also super interesting. But what happens, like, if you get hacked on your retinal scan? I mean, it's not like you can change if you get hacked on your credit card or your identity, you can sort of change that and fix it. I don't know what happens if your retinal scan is your retinal scan, right? So there are lots of things to consider, ethical as well as security and accuracy in this era of what is the computing device going to be, and if it's collecting biometrics, it's probably going to be purpose for a lot of different things, right? So I don't know. I mean, I don't know the answer to your question. I just try to track all the technology and integrate the stuff that's promising where and when I can.
Yes, again, I mean, it's incredible how the space is going to look like in the next, I want to say 5, but the way, the speed with which this has moved. I mean, I think we could see incredible things even in the next couple of years, or in the next 3 years. How do you see this evolve in how we deliver care in our clinics and at the bedside in hospitals?
I mean, the immediate opportunity for us, I think, if we're open to it as clinicians, is to start to, take this great world of illiteracy that exists in our patients, no matter how educated they are almost, and start to make them literate. The reason I don't like consumer devices that just come up with algorithms and give you some sense of your readiness score or something is because I think we all need to be speaking the same language. So when I go over Health Kit or Apple Watch tracings with a patient I'm seeing in the hospital or in the clinic, I'm showing them how to get into their phone. I'm educating them on the trends in their heart rate, on the differences, day, walking, sleep, heart rates, looking at heart rate variability, arrhythmia detection, showing them how to send me an EKG should they feel something, and just starting to develop this healthcare literacy. But that stack that Apple has, it's not just like the watch if they have it. There are other things they can connect to, whether it's their connected blood pressure, and just trying to give them a dog in the fight create, because if you're illiterate, you're also not curious, you're also not engaged, right? So it opens a world for them where they actually can have some sort of insights and autonomy and partner better with us. And I find it to be very efficient because patients start to do the hacks on themselves and learn things, and then they bring you the quote proof. For instance, they'll bring themselves diagnosed, which is always fun, but they'll also bring the proof if they have their blood pressure numbers on how a drug is impacting them, or another health condition, or how is impacting their cardiac condition. So I think being open to these solutions, learning how to use them, is very important. Medical centers, very few medical centers even have chief AI officers, right? I think Cleveland Clinic just hired one. But having, if you think about it, medical centers really should all have, particularly for cardiology, nurses or other trained professionals whose job is just to figure out how to use consumer devices to give patients and doctors more information about their health status, right? So that we can get a more complete data set, a more complete picture of the health status of every patient, and that patient themselves has a deeper understanding on how to drive beneficial outcomes for themselves. So I encourage the use of glucose sensors. Now they're available. CGMs are available now to consumers, and people can afford them who are overweight or not overweight to guide their nutrition. I encourage stuff I never even thought about, or sleep tracking, to try to understand what are some of these relationships between arrhythmia burden, sleep, stress, whatever. But the problem is in the software, because while Apple has a good stack and has things like HealthKit that medically regulated and other devices can connect into, there isn't that sort of killer software out there that you can't go to the App Store and go, this is the heart failure app that I'm going to gauge my patient around. That's also going to include diet and meds and all that stuff. Medically regulated companies, even if they're collecting a ton other than glucose monitoring, the same companies that might have CGMs and have an implantable device business as well, they're not giving patients data in a way they can understand from devices that are implanted in them. It could be a hip implant with sensors on it. Why aren't we developing the apps that engage patients in their own care? What are we afraid of? Why aren't we doing that? We need them to be more educated and more engaged. It makes zero sense to disenfranchise them. We don't do that in any other aspect of digital life. Airbnb, right at your fingertips. Screw the hotels, screw the record companies. You can get any song, anytime. As you know, everything is about the democratization of information to empower the individual who wants that service. We need to completely change our minds about our model of healthcare and flip that script so that we can, provide that to people. I think as a service, because I'm frankly, I think most of us who try to do stuff well, I sort of got sick of failing everybody, because the one time I didn't talk to the orthopedist or some other entity that was involved in a patient's care, including a family member. It is so hard to knit this stuff together without digital and without software solutions. Why do we even try? We fail. So that's the kind of service model. We talked about the hardware model. The thing we haven't talked about that's critical and keeps me up at night is, how do you protect all this data once you start to get it so it doesn't do people harm and exploit them, because you look at digital and you look at cybersecurity and hospital systems that have been taken down through, state actors, or just, just cryptocurrency, thieves, and how digital can be weaponized to actually kill people. Imagine there's a hack in a hospital system, just in an ER. There's a terrorist attack, and you're getting the wrong lab data, and you're being weaponized. You could kill a patient. The potassium's 2.5. You give them potassium. What if their potassium's 4.9? So how do you protect with the kind of future I'm talking about, which is massive amounts of data off of people all the time, not just within our bricks and mortar, right, that can be hacked? How do you keep it safe? How do you keep it from being exploited? How do you keep it from being weaponized and exploited for its value on the open market, or for a foreign actor, whatever million ways this can be purposed, right, for evil? how do you protect it enough and to assure its ethical use is a place I spend like 40% of my time because it's the dystopian part of all this. And potentially it's just as likely to play out as what I'm talking about, which is, amazing healthcare for everybody in advance of chronic disease. So I don't know, but that aspect of it is important. And maybe it's the same AI or the same AI. AI can be a great security product for stuff like that, and they exist for cybersecurity. And it also introduces another potential like attack surface. So all of this stuff is double edged. Um, it's a huge challenge and problem, right? We didn't have this in the days of paper records where you could secure a facility and secure a record, right? It was just about would anybody talk about somebody? Now it's just so much more complicated to think about protecting it and sharing it when it's not protecting it when it has the ability to really advance a public health problem.
Yeah, it gets convoluted, with protection. Well, I mean, there's plethora of data. Like there's data everywhere, and I think how to protect, and it's ubiquitous and it's only increasing. So it's sort of like it's the ever expanding universe of data, just like the universe is ever expanding. And the question is how best to secure it, like you mentioned. I think the one other aspect of it, which as uh, I was listening to you, I was wondering the litigious aspect of empowering our patients with some of these data. I mean, do you think the judicial system and the healthcare laws are in place to safeguard physicians when patients get empowered with data from these variables? Because that is the biggest, well, one of the biggest concerns.
Yeah, I do. I mean, I don't think it's that big of a risk. It's like it's not enough of a risk to keep people dumb and down on the farm, because we control so little of it. We're so busy we can't. Um, no, I don't think it's a big risk. Like I can't even envision. Okay, somebody, you're you do a procedure and you put a watchman in somebody, or you do a TAVR in somebody. They go out, their Apple Watch tells them they have AFib, they have a massive stroke. I don't think that blows back on you. Maybe they called the person on call and they didn't get a NOAC because they were asymptomatic. Or maybe they weren't on. I don't know, but I don't necessarily think that blows back on you. I don't certainly think the small risk of that is a reason to to say we shouldn't do things like that. I think the legal system. I mean, my impression of just the government right now. I mean, just when I listen to our legislators and stuff, interview heads of large, that the understanding of technology doesn't feel that complete. So I think, it's always going to lag behind. The regulation is different though. I mean, there's a very reasonable regulation on software as a medical device. What constitutes regulated software, to what level, what is it doing, what is the provenance of that software, in the same way that you would ask, if you're going to put an implant in somebody, you better know where every component of that implant came from in case there's an issue, right? Better be able to track it. So I think there's some very reasonable legislation around software and software as a medical device. There's starting to be some guidance around use of AI. The problem with the AI is I think a lot of people who make some of these AI products themselves don't fully understand them. And they've hit the marketplace so quickly, right? That, and they're, I'm sure your medical center, I know my medical center, they're buying tons of AI products for a bunch of different reasons, right? Efficiencies, billing, overcome the limitations of the EMR, things like that. Some of them are really quality of life things for physicians, right? But I don't think we fully even understand what we've bought. It's a little bit of a big experiment. As you know, many large organizations have had to develop whole new structures around their AI governance and development, release. it's pretty interesting time. But I don't think any of this should really keep us from innovating and learning because, you learn as much from your mistakes as going through training. I hate to say this, but it's true. You have to make the mistakes so you can learn the lessons. And don't you want to be an early learner? Think about any new technology or procedure that you've delivered, how, you know, I mean, you want to be an early learner, right? It's a huge advantage, I think. So, uh, yeah, it's unclear how it's all going to play out.
Yes, no, I mean, I agree. I think that there will be a learning curve, and the less steep that learning curve, the better it is for all of us. Um, and AI has started to integrate with our EMR, certainly in my health system. Sort of identifying disease early. Helping us garner insights into valve disease in particular. And helping us identifying patients who may not have seen a cardiologist and have a diagnosis of valve disease hidden somewhere in their echocardiography report. So AI certainly has, and also there are technologies where just based on EKGs, and I'm sure you know this, based on EKGs, and based on a CT scan, based on even CT scans done in the ER for other indications, who can very accurately tell you patients with subclinical atherosclerosis or even aortic valve disease, which is fascinating technology. That's all AI, and I think that's all AI um, integrated well with an existing electronic health record or electronic medical record. Some of the challenges again are these HIPAA compliant, and are certainly the idea is to enhance patient care and have an earlier diagnosis of some of these life-threatening conditions. But at the same time, making certain that um, they're compatible with existing healthcare laws is, I think, where we need to be attentive on that aspect as well.
Yeah, yeah. I mean, it's just so constraining, right? I mean, like even with COVID, so we all saw, 20% or something crazy number, like 20% of America moved during COVID. And so we all adopted telemedicine, right? And all of our patients moved and we continued to follow them. And then as soon as COVID was over, people were saying, okay, now you can't follow anyone who's out of state. And it's like this arcane laws with state by state licensure, right? When you suddenly can't follow a patient anymore because you're not licensed in that state and that exemption no longer applies. And then the security issues we're talking about with data are so beyond HIPAA. And the EMR, I mean, you had Callum McCrae, and he so well articulated how the EMR is actually stop our EMRs are such a poorly designed software that they've actually, you know, hampered innovation and our ability, like in the incidents you gave him, to understand what antiplatelet regimen a patient should be on when there's a simple test after a coronary intervention, right? Because we have the type of medical record system that inhibits discovery in that way. I don't know if you remember when Google, they took all the books from the Library of Congress and they didn't ask anybody's permission, and obviously authors didn't like that, and they published them. Um, but they also wanted to do that with the EMRs that we had. They wanted to be the dominant cloud-based EMR, and they wanted the EMR in the cloud to relate to the pharmacies and all those things. Well, if we would have done that, again, I'm not making a statement about whether you give that much power to Google or not, but we would have had a lot more ability to do the things you talked about in that interview with, like, understand what is the best drug for a particular patient, right? That the EMR and the constraints of the EMR and our billing system just force us to do the wrong way. So I'm just kind of fatigued by, the limitations of our current tools. And, I don't plan to spend another minute of my time, worrying about, I'm still getting outside information, having to go for a PDF into the EMR, completely non-searchable. Companies have lost great fortunes trying to figure out how to integrate their real-time important diagnostic data with an EMR because they're trying to conform an amazing breakthrough technology to an antiquated system, right? They can't ingest it. So I'm just thinking beyond that because it's too much pain and suffering for me to try to work within it. I'm not saying I'm breaking the law, I'm just saying I'm not designing it within that system because it's too limiting.
Yeah, no, I understand. I mean, EMRs, and we can, I mean, we can all talk about the evolution of EMRs and, how EMRs, are designed or were designed to sort of help the hospital systems and the billers and the coders and not essentially physicians and patients. Well, I mean, but back to what we were talking about, and I think it's been a fascinating conversation. I've learned a ton. I'm excited for the future. Thanks for all the work that you've done in this space. I mean, you sounds like you've access to and you've seen technologies in this space which sound pretty futuristic even to me right now as I was listening to you. Is there anything you think we've not touched upon or covered which you think the listenership will benefit from listening from you?
Well, I mean, I have a lot of respect for what we do, and for those who are listening to me, I would just say, we're keep doing it because we're making a difference in people's lives. But I think, jailbreaking data and healthcare services to patients in the right way will only improve the quality of our lives, our ability to make insights, and really at the margins use our expertise, right? So that's that's what I'm talking about. And to kind of now, this next era is about breaking out of our subspecialty silos and looking at people as systems and using data and AI to assist that. And that's really, I think, it's an incredibly exciting time, to be in. But and I appreciate the opportunity to be on your awesome podcast.
No, thank you. Again, it was a true delight and a pleasure to have you. We've learned a lot from you. And to our listenership, do send your comments to us if you have any questions specifically for Dr. Saxon. You can email us or you can email her. We'll, include her bio in our show notes. And if you can follow some of the work that she's doing in Southern California. Keep listening. Thank you for listening. And until other Monday, we'll see you back then. Thank you.
We hope you enjoyed today's podcast produced by Radcliffe Cardiology in association with makeadent.org. We aim to bring you a new angle of all things cardiology every second week. Review us on your favourite podcast app or send your comments or questions to podcast@radcliffe-group.com. To view the series, head to radcliffecardiology.com/podcasts/Parallax. Thanks for listening.